Okay.
Now I will show you how easy we can do exactly this shape. I will start from the beginning. So new single component. And now let's start. And let's make it, let's say 60. Otherwise, our default value will be very small. So let's
Okay.
say 60. And now you just draw without thinking about any distances. So only the focus is the shape. So
Okay.
I will start from here up to here, then something. You see, I need this perpendicular relation. Fine. Then up to here, even I will not go here, because if I want to make my tank a little smaller, I want to give this opportunity by a parameter. So I will not go up to here, up to here. Now again, perpendicular, then something like this. Now I will take care this vertical line to reach my level, you see,
Ah,
because
nice.
now when I'm drawing this horizontal line, the system will make collinear relation between the right one and the left one.
Okay.
And later, we don't need to put two dimensions for these two slots. I will put only one dimension, and because of this collinear relation, the other will be repositioned automatically. This is another trick.
Okay.
Okay?
Cool. Yep.
Then perpendicular, and then let's go up to here. And we are ready. And
Nice.
now, of course, we need a creasing line here. Let's do it. You see again, collinear relation, it's
Yep.
perfect.
Okay.
Okay. And now, let's say this is our panel or tank height.
So to come in and start actually defining what's going to be resizable, we're using
Yes,
dimension lines, and then we're giving the dimension lines a variable name.
yes. In fact, we create a parameter which is automatically connected to this dimension.
Okay.
We create parameter. This is our parameters list view.
Got it.
And you see, I don't care about the value. We will round these values later. Now,
Okay.
the focus is to put all necessary dimensions in order not to have any geometrical assumptions.
Got it.
Okay, so then let's say this, I will call this slot. So this will be my slot width. Then we have to position to put a dimension to fix the position of this line, because now you can move it left and right, you see?
Mm-hmm.
So between now, of course I can say between this and this, but I don't like this approach. If I have a line, I always will use a line. So between this line and this control point, or even with this axis, because this is our y axis. But you can use the control point, because we at least have one line here. So between this line and this will be, for example, our slot length, for example. And then to define this, the position of this line, we have two approaches. It depends on the idea how this component will be used later. The first approach is you define this distance, or you define this distance, how
Okay.
much to decrease it. So if we use this approach, I will call this tank length, for example, because this is some kind of a tank.
Okay.
Okay. And now what else we need? We need to do this dimensioning also on this side. But we will skip this dimension, because you see, this is collinear to this. So
Okay.
this will move both of them. Can you see on double
Yes.
click?
Yeah,
Yeah,
definitely.
yeah.
So we just
But
need we just need to get the slot width and the slot
you
length
see,
copied over.
we have here still freedom, and here we still have a freedom. You
Okay.
see? How
Yep.
you figure out where is your freedom? Now if I run in relation tab this button, check for geometric assumptions, the system highlights, you see, highlights the problem control points. You see, when it
Yep.
is highlighted, it means that here, somewhere here, you have a freedom. You see?
Yep.
Uh, let's say, so when we fix it and we run again the solver, we will have some highlight here.
Okay.
So Now let's fix this distance. With this, if you want to have symmetrical component, I will use the same parameter, TL, like for the left. And
Okay.
now let's demonstrate again. Again, a freedom. Okay, yes, you see, again, this is can be moved because when I move this, the upper corner is moving, you see?
Yep.
Okay, so now from here to here, the same SL parameter. And now let's check. No assumptions. No assumptions. And now you can make here some nice distances. Let's say 15, I don't know, 2 or 3, doesn't matter. The length of this, let's say, not the length of the SWOT, let's say 5. And now if I make this 7, it will go outside my control point. It's up to you. You can make restrictions by minimum and maximum. If I
Okay.
say the length of the tank to be not to go, my tank not to go outside my control point of attaching, I will say maximum here SL. But
Okay.
it's up to the construction, how it will be used later. Okay?
Got it. Yep.
Yeah.
And then
And
we need to do the radiuses, right, on the top.
now we will make this rounding. So fillet, and even I can create a parameter for this rounding. Very often we use in our constructions FR, fillet radius, because this object is fillet. So
Okay.
FR, you give a value, let's say 1, a default value, and then you say here and here. I forgot to use the cutting style, but however, let's put it here again. Now I will make this, of course, cutting.
Okay.
And now this parameter will take care about left and right rounding on the top. If you want to have different rounding for this and this, you need another parameter. For example, FR1, let's say 2 millimeter. And now you round here.
Nice.
So now this is responsible for the bottom. This is responsible for the top.
Okay. And then
And
we have to make all those global, don't we?
yes, but before this, let me show you something. So we have here 15. Minus 3, we have 12 here.
Okay.
I will make this 7, and I want to make this 7 again also. Problem.
Yep.
So we can take care even for the maximum of one of these radiuses, even for this. So first of all, let's go back and let's think about this rounding. This rounding should not go below this level.
Okay.
So we have TH minus SWOT width.
Yep.
So the maximum for this should be tank height, TH parameter minus SWOT width.
And then also, don't you have to subtract FR1?
Now for FR1, I will put another restriction. So FR1, the maximum should be this distance again, which is TH minus SWOT width minus rounding, because
Okay.
the
Yeah.
maximum of this should reach this control point. So minus FR.
Okay. Cool.
And now if I make this, let's say 3, and this I try 20, you have, oh, very nice. You see now, up to here we reach the control point, but we have another option. We here, this is not enough. Let me show you. This rounding should not be longer than this point on one hand, and on other hand, to this point to touches this point. So
Okay.
we should choose for the maximum for the radius, minimum between another two values. This is the first value, and the other value is this TL. So here I will say, give me the minimum between this distance, which is parameter TL, and this value, which is a formula.
Okay.
So now if I make this 30, the minimum in our case is 5 because TL is 5. This is longer, bigger. So the maximum is TL in our case. TL TL is 5. Yeah, because it has also a restriction because of SL.
Yep.
And that's it. Yeah.
Excellent.
So it's very useful to put some restrictions in the component itself.
Oh yeah. Well, it takes the user error out.
And
Very
by
nice.
default, you can use, by default, even you can say to have two identical rounding. So you can say FR1 to look in FR. So you can put here FR. By default, you can edit it later if you want. Yeah. So this is in general. The last step is to make all this global in order to be able to change this later when you use this. And we forgot something else. We should put overlapping flap on these 3 lines because when you attach them on over another component, we should hide, let's say, the cutting edge from the other component and to apply these styles, which is coming from this component. So you say set overlapping flap, set overlapping flap, set overlapping flap. If you want, you can even create a new group for this in order when you use this component, all these parameters to be in a special group related to this. Let's say if we call this a tank, we could create here a new group, tank, and you can move all this, move to tank.
Okay.
You can rename this also because this is what you will see later as a name of a component when you use it in a resizable file. So let's say tank. There was another thing. You have now a lot of dimensions because your structure to be well constrained, but you can hide some of them because now it's overcrowded.
Okay.
So you can say on this side, I will leave, for example, this. So let's hide this. Okay, we can leave this and this also. And on this side, I will leave this, but I don't want to see. It's nice. We can hide this from here and to have it here and here. Here you can hide this also and this. And now you don't have so many parameters on the
It's a lot
screen.
cleaner. Yeah.
They are working behind the scene, but you don't see them. Yeah.
Excellent.
And now you save it in a special folder in order to use it in your EngView software. Let's say. And now when you start a new project and you start with a base, this is just an example. And now you use this. Okay, of course I have to close it in order to use it. Okay, and now
nice.
We receive all these parameters even in this new group.
Excellent. Now,
and you see the creasing overlaps the cutting. And you put a dimension not between two parallel objects, but between two control points.
Okay.
And when you put distance between two control points and later you want to round here, the system says I need to keep this control point because of these dimensions here. So I always suggest if you have lines, collinear parallel lines, always to put this dimension between parallel lines. Now,
Okay.
now if you round this, everything will be fine. No dot,